So let's start our lecture. So today's topic is finite automata with outputs. So onwards we will see this finite automata with output. Okay, so we already discussed had inputs associated with them and there were no outputs. So in the FA with output, so we will see that along with the inputs that are also output that given in by this automata. So now let's see there is a two kind of finite automata. We already know that inputs, how inputs associate with them, and there is no output. So in our finite automata with some outputs. So let's see there are two kind of things. First one is a Mealy machine and second one is a Moore. Okay, so let's start this Mealy machine. We start with this Mealy machine point. Now look here, Mealy machine there is a Mealy machine. So we define this Mealy machine. How we define this Mealy machine? Mealy machine defined with these 6 tuples. We already know what are the tuples. Tuples are sorry, delta, sigma, lambda, q naught. So in Mealy machine there is a 6 tuple. With 6 tuple we define this Mealy machine. Let's write it here. How can we show that tuples? Those are the symbols for that tuple, for those 6 tuples. Q, sigma, delta, del, lambda and q0. Those are the main 6 tuples. Now let's write it here. So let's start with this Q. What is the Q? Q is a starting finite set of state. We already know that our Q mean is the finite set of state. So this is the same like our DFA where Q is the set of state. So write it here. Q is a finite set of states. Now move on. Next one is our sigma. Right? Sigma is the finite not empty set of input alphabets. So this alphabets is the same like before we were sigma is the set of input alphabets, same as it is. So just write it here. Finite non-empty sets of input alphabets. Okay. So move. Next one is our delta. Write it here. Delta. What is the delta? Delta is the output alphabets. Now this is the new things and something different that we see on our So I already told you. Now we discuss about this one. So finite automata with output. So delta define the set of output alphabets. So did we have this? So write it here. The set of output alphabets. Okay, now move on. Next one is this one. Next one is the del, our del. So write it here, del. So del is a transition function that maps the q cross sigma to q. First we write it here. This one is a transition function, right, with q cross sigma to q. Okay, now look at here, this transition function q cross sigma to q. Now next one is our lambda. So write it here. So this one is also this one is also DFA that we discuss. So lambda, now let's this lambda, we know that now this again something, it's something different. This lambda is the output function that maps the sigma cross q to del. That what is mean? Let's first write it here, then I will explain. Output function to del. So what we write here? We write here sigma cross q to del. Correct? So what does the mean? This one is something different. So that is the output of this Mealy machine. It will be associated, or it will be defined by the state it's currently present and the input symbol associated with the states. This will be completely when see. Okay, we will see this example. For right now, let's again revise this 6 tuples q sigma delta del lambda q0. Q is a finite set of state. This sigma is a finite not empty set of input alphabets. Del the set of output alphabets. Then lambda output functions. Sigma cross q to del. This one is a new one. So now small example. We will see this with this small example. Let's start. Just look this figure. It's simple. A getting on input 0, B getting on input 0, B in self state getting on input 1, then A getting on input 1. Because each and every state we know it's getting all inputs with this 1 and 0. What are our inputs? Right? So now look at here. We write here states because this is going to be next term. We will discuss these things right now. So let's start this example. Let me explain this example first. Let's see, here we have as a string state and we have another state B. This state A and this state B, right? So getting on input 0 with A state B, and on getting on input 1 it goes to A, its self state, and it's produce the output B. Okay, so look at here, this one A, this one is the input, and with getting a it goes to self state with B. Okay, so now look, with input 0 and getting on input 0 it goes to B and produce this output small a. Correct? So this is producing the output and this one is the input. This one is the input, this one is the output. Right? Now look at here, this next state, B our next state. For next state B, on getting on input 0 it goes to A state and produce the output B, small b. Correct? So we see that there are outputs associated with each inputs and kind of state they are present in also here. So all inputs are also present and all outputs which produces by this state, this also presents on here. This means where it goes to and with this output with inputs. Correct? So this we said that the output function is defined by this one. The output is the input and current state also they mentioned is associated to the with all these things. So look at here this example. See this the output small b and how it is small b. This small b define how to do. We get this small b. We get the small b when it goes and which one is the state and with input 1, and this b defined by the state a with the input 0 and this also rise to the next state and then also it's goes to completed with this 0 and produce the B output. So let's move on the Moore machine. Now let's see, there are also 6 tuples, so mention it here: Q, sigma, delta, del, lambda, then Q0. We already know those things, but again we saw these things. Let's see, Q is a finite set of state, correct? Then sigma, this sigma was finite non-empty set input alphabets, okay? Finite non-empty set of input alpha bit, correct? Then next one, which one? This delta, the set of output alphabets. We already know that the set of output alphabets, okay? Now next one is the del. What is our del? Del is a transition function. Now, so Q cross sigma to Q, correct? Now lambda, let's mention here lambda. Lambda is the output function. Then final is Q0, initial state or starting state. Correct. So let's see example of Moore machine. For the example of Moore machine, let's see example this. I will draw this diagram first, then I will explain. Okay, with inputs. Now, so previously we saw this one is one Mealy machine, this one is Moore machine example, right? So what's the difference between, it's getting an input 1 and produce the output, but here let's, but this diagram, this state with produce the A output and getting an input next state, correct? Means A is producing output. Now first of all see, there are two inputs 0 and 1, but when 0 it comes, getting an input 0 to the B and then it produces the output B, getting an input 0 coming to self state, okay, and also produce the output B. But when input 1 is coming, it's getting on input 1, it goes to A state and producing the small a output, right? So this the two examples of Mealy machine and Moore machine. In next lecture we will see another example of Mealy and Moore machine.